So unit 4, day 3, although it's really only the second day of notes. And this one will be similar in that we do 1 day, or you get all the notes, and then 2 days to work on it. So if you don't understand everything today, that's okay, because all we're going to do tomorrow is work on related rates again. And then we have 2 days of review. So if it doesn't click today, you'll be okay time-wise. All right, number 1. Y equals 5x squared minus 6x plus 2. Find dy dt, not dy dx, dy dt, when x equals 4, given that dx dt equals 2 when x equals 4. Ugh, that's a lot of information. So maybe it's helpful to try to write down what we know and what we're looking for. Given x equals 4, dx dt equals 2, and we want to find dy dt. Okay. Well, I've got an equation with y's and x's in it. If I want dy dt, I need to take a derivative with respect to time. So that denominator is important. Take a derivative with respect to time. So all the rules are the same, but we're going to have dt showing up. So that means, I guess we'll go a little bit overkill here. d dt means take a derivative with respect to time. So I'm going to d dt, take a derivative with respect to time, of both sides. Because when I do that, dy dt will show up. So on the left, dy dt. On the right, slow down, let's think about our derivative rules. What's the derivative of 5x squared? 10x. I like that. That's a good answer based on the question I gave. But what if I said, what's the derivative of 5x squared with respect to time? 10x and then dx dt, because we're dealing with x. So 10x dx dt. What about the derivative of 6x with respect to time? So do the derivative first and then worry about with respect to time. What's the derivative of 6x? 6. But if it's with respect to time, I need a dx dt on there. And how about the derivative of 2? 0. So it doesn't matter what comes after that. That's just 0. Okay. What are we trying to find here? Find dy dt. Okay, so this is a good one. Dy dt is already by itself. There's no algebra involved. It's just plugging things in. So let's plug in x equals 4 and dx dt equals 2. Like we have everything we need. So dy dt. And then to communicate that you're plugging in x equals 4, like I don't need to say both of these things. It's easier to say it this way. That little bar there means at x equals 4. So that's a way to communicate that a little bit easier. So 10 times 4 times 2 minus 6 times 2. That's a safe stop. But let's see. 80 minus 12 is 68. That's dy dt when x equals 4. So we've kind of done that already with implicit. The reason it's called related rates is because there's two rates going on. Dy dt is a rate, dx dt is a rate. They're related to each other, hence related rates. Now, that's the most straightforward kind you can get. Usually they're word problems like number 2. a pebble is dropped into a pond, causing ripples in the shape of concentric circles. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4, find the rate at which the area of that circle is changing. That's a lot of information. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. So what does that mean? How do I turn that into a variable? How do I turn that into math from English? It's a rate, so I know it's a derivative. So it's d something, oops, there's the other something, dt. So what's changing? So let's say it's dr dt. The radius is changing at a constant rate of 1 foot per second. The units can be super helpful because the units should match the variable. dr dt, radius over time, so length over time, feet over second. So you can use the units to help you figure out what the variables are. When the radius is 4, so when r is 4, find the rate at which the area is changing. So what am I trying to find in terms of variables? What's the variable that would say that represents the rate at which the area is changing? Right. Rate suggests derivative, and the derivative of the area. So we want to find dA dt, because that would be the rate the area is changing. Anything dA dt, dr dt, dy dt, those are rates. So this is the rate that the area is changing. This is the rate that the radius is changing. Even back here with x's and y's, dy dt is the rate y is changing. Dx dt is the rate x is changing. So part of the problem today is being able to interpret English and translate it into math. And so rate is the big giveaway that you're talking about a derivative. Okay, so I've got a's and r's. That last one gave me an equation. This one did not give me an equation. So it'd be nice if I had an equation that related A and R. Think of any equations that relate the area of a circle with the radius of a circle? All right, now you're just asleep. So let's pick on somebody. Ava, what's an equation that relates the area of a circle with the radius of a circle? Like, how about what is the area of a circle? What's the equation for the area of a circle? So there's some basic equations that we just expect you to know. The area of a circle being one of them. Somebody help her out. What's the area of a circle? Go ahead. Lauren, you got it? Pi r squared. Area equals pi r squared. So, yet another day where something we learned long ago, we just need to know. We don't have time to revisit everything. We just expect you to know some of the things. Like, you can take a quick glance at number 3. We give you the volume of a cylinder. But area of a circle, we expect you to know that. All right, I want dA dt to show up, so it would probably be wise to take the derivative with respect to time of both sides. start picking on some more people here. People I have absolute confidence in, though. Quinn, this one's tricky because it's easy. If I take the derivative of a with respect to time, what do I get? Yes. dAdt. All right, Gregory, you got the harder side here. What's the derivative of, with respect to time, of pi r squared?
I have no idea.
Okay, well, let's back up. What's the derivative of pi r squared? Power rule on r squared.
2 pi r.
Uh-huh. But we're doing it with respect to time, so I need one more piece to that. What's the derivative of r with respect to time? Like, that sort of is the answer. dr dt. If you take a derivative with respect to some other variable, then you're going to get an extra dr dt showing up. Let's see, do I have enough information now? I'm looking for dAdt. They give me r, and they give me dr dt. So I think I'm ready. dAdt when r equals 4, 2 pi. I'm going to put the units in on this one. Most of the time you won't do this, but it'll help you see that, I hope it'll help you see that the answer makes sense. So 2 pi, r is 4 feet, and dr dt is 1 foot per second. So my answer then is 8 pi. What would the units be? What's feet times feet? Feet squared per second. Does feet squared per second make sense as a change in area over change in time? Area over time, feet squared per second. So again, most of the time, most of you just sort of ignore the units, and unless they're asked for, you don't have to provide them. This was a discussion on my favorite Facebook group yesterday. When do we have to give units? Only when they're asked for. But they can still help you make sure or make sense of the problem. Feet squared per second, that's a dAdt. That's an area per time. So I feel good about that answer. But again, you only need to give units, or you only must give units when asked for. So I feel like that's like a little different than physics. Physics, we always want units. Your answer is incomplete without units. And usually even in math, your answer is not finished until you get the units on there. Less so here. If we want the units, we'll ask for it. On the AP exam, there's always 1 or 2 free response questions or parts of free response questions where it'll say, like, what's the unit? And if it asks for the unit, you know there's a point attached to giving the unit. Ian?
Wait, why is it feet squared?
Okay, 2 reasons. One is feet times feet gives me feet squared. The other way is to not worry about it on this side, to just get it from here. I know area is in feet squared. I know time is in seconds. So my answer has got to be in feet squared per second. So there's sort of 2 ways to approach it. If it's asked for units, you can know what the units are before you even work the problem, because you know what area over time is. Sort of the longer way is to include the units and see if it makes sense with what you think it should be. Number 3. Water runs out of a conical tank at a constant rate of 2 cubic feet per minute. Okay, so there's our conical tank. Water's dripping out of there. Or flowing out of there, I don't know, 2 cubic feet per minute. I don't know if that's a lot or not. I guess let's read the whole question and then we'll go back and figure out what we know. Water flowing out at 2 cubic feet per minute. The radius at the top of the tank is 5 feet, and the height of the tank is 10 feet. So that's not necessarily where the water is, that's just for the tank. R is 5, H is 10. How fast is the water level decreasing when the water is 4 feet deep? The volume of a cylinder is 1/3 pi r squared h. Okay, so let's see let's go back and try to translate this problem from English to math. Water runs out of a tank at 2 cubic feet per minute at a rate 2 cubic feet per minute. So what is equal to 2 cubic feet per minute? What variable is that? Feet cubed is volume, but this is not a volume. This is a feet cubed per minute. And it's a rate. That's your hint that this is a derivative. So what derivative is it? dV dt. Because our volume is changing. dV dt. Cubic feet is volume. Per minute is time. And it's a rate. So it's dV dt. Alright, the radius at the top is 5, the height is 10. Okay, again, be careful. Those aren't changing. That's like tank dimensions, not water dimensions. The water is changing, but the tank is 5 and 10. How fast is the water level decreasing when the water is 4 feet deep? Okay, so when h equals 4, what are we trying to find? Do you know? How fast is it decreasing? That's a rate. So we're looking for a derivative. So d something, d something. Everything's with respect to time in this problem. So what's changing? What are we trying to find that's changing? dH dt. So we want to figure out how fast the height of the water is changing. So that's dH dt. Okay, let's see. Do I have everything I need? dV dt is 2. You know what? There's one thing that I kind of missed out on that I might catch later if my answer doesn't make sense. If the water is running out of this tank, then this dV dt, my volume is changing, but my volume is going down. So my volume is decreasing. Speaking of signs, do we expect dH dt to be positive or negative? As my water drains out of the tank, is H getting bigger or smaller? Smaller, so I expect dH dt to be negative. So we'll work the problem, and if we don't get a negative for dH dt, then we'll have to go back and figure out what happened. But I think that'll be negative. Okay. The reason it gives me that R is 5 and H is 10, that's trying to tell me that there's a constant ratio between those two. That, and we can do this either way, R to H is 5 to 10. Always. Right? They're not always 5 and 10, but that ratio is always 1/2. You could phrase it this way. R is always 1/2 of H. So even as it drains, R is half of H. V is 1/3 pi r squared H. I need to take a derivative with respect to time, but before I do that, like if I do that right now, the left side's easy, dV dt. What am I going to have to do on the right side?
Why everything else not dH dt?
Even before we get to derivatives, what will it take to get a derivative?
Product
the product rule. So, and if the product rule shows up, then I have drdt and dHdt in my problem. And I don't know anything about drdt, and I'm not asking anything about drdt. So this would kind of be a mess right now. So it would be nice, or can I have an equation with only v and h? Right? Everything in my problem is v's and h's. There's no r's in my problem statement. So I'd really like to deal with v's and h's if I can. That way I'd avoid the product rule. So is there a way I could get rid of r? Is there something r is equal to? 1/2 h. So I'm going to make my life, well, the algebra is going to be a little bit harder, but it's well worth the price to pay. Let's see, r is h over 2. So I've got a little bit of an algebra problem, but it's going to make my calculus a whole lot easier. So try to get your equation into, two variables, and then, I assume this is obvious, but maybe not. Simplify before taking a derivative. Simplify before differentiating. Right, you wouldn't take a derivative of this right now. We'd clean that up, then we'll take a derivative. So let's see, h squared over 4. 3 times 4 is 12, so pi over 12 h cubed. Everybody okay with where pi over 12 came from? Again, we do algebra quick in here, because we're not worried about algebra, we're worried about calculus. Okay, so now I've got an equation with just v and h. This is going to be a whole lot easier to take a derivative of. Take a derivative with respect to t of everything. So left hand side, easy, dv dt. Right hand side, let's see, pi over 12 times, what's the derivative of h cubed? We'll go with this step by step. What's the derivative of h cubed? 3h squared. But what's the derivative of h cubed with respect to t? I need a dHdt on the end of that as a chain rule thing. Okay, let's see where we stand. dv dt I know, h I know, and I'm looking for dHdt. So I think we're ready to just plug things in. dv dt is -2. I'm going to reduce the 3 and the 12 to pi over 4. H is 4, so that's 16 when I square it. dHdt. Alright, so this is just algebra from here. -2 equals 4 pi dHdt. And then I'll divide both sides by 4 pi. dHdt equals -2 over 4 pi. That's a perfectly acceptable safe stop. It's also easy to reduce. -1 over 2 pi. Okay, negative. It's always good to check your negatives to see if they make sense in terms of the problem. So I know you usually don't like word problems, but because they are word problems, we can make sense of their answers. Does it make sense that our h is negative in this problem? You mentioned this earlier, yeah, because the water is draining out, so that height is getting smaller. So I'm good with that h being negative. Now, this didn't specifically ask for units, and I didn't keep up with units along the way because it would have been kind of a pain in this problem. But I can know the units just by knowing what I'm looking for. So what would the units of dH dt be? Ian, what do you think the units of dh dt would be? All you gotta do is tell me the units of h over the units of t. Feet over. Yes, but be careful. What is the unit of time in this problem? So look back through the problem. Where is the unit of time? So all the links were in feet, and the time is in. It's only said one time in there, but it's in there. Feet per minute. So I did not get the units like the official way that time. I just went to the end and said, well, h is in feet, time is in minutes, so my units are feet per minute. So units are pretty easy because you can get them by what's being asked, not necessarily from working the problem. Number 4. I may not get through all these today, and that's okay. Number 4. A 13-foot ladder is leaning against a wall. Suppose that the base of the ladder slides away from the wall at a constant rate of 3 feet per second. How fast is the top of the ladder sliding down the wall? When that's supposed to be when the base of the ladder is 5 feet from the wall. Okay, a picture perhaps. So a 13-foot ladder leaning against the wall. Suppose that the base of the ladder slides away from the wall. So this point is going away from the wall at 3 feet per second. How fast is the top of the How fast is the top of the ladder sliding down the wall when the base of the ladder is 5 feet from the wall? Indicate units of measure. This looks like a right triangle. You know any equations that tell us about sides of right triangles? An equation that tells us about sides of right triangles. What is it? Pythagorean theorem. A squared plus b squared equals c squared. So for this particular problem, let's call this x and y and 13. 13 isn't changing, so I can use 13. Be careful with x, like we said, when the ladder is 5 feet from the wall, so when x is 5. But that's changing. So I don't want to plug in 5. I want to use x and y. X squared plus y squared equals 13 squared. Okay, well, if I'm calling this x and this y, what is 3 feet per second in terms of variables I'm using? What's changing by 3 feet per second? X is changing, so that's dx dt. And this up here we don't know, but what we're looking for is dy dt. So let's take a derivative of the Pythagorean theorem with respect to time. So Tyler, you get the hard one. It's not really hard, it's just first. Addie can just follow your lead after you give us a good example here. What's the derivative of x squared with respect to time, Tyler?
2x dx dt.
Good. All right, Addie, just follow the example here. What's the derivative of y squared with respect to time?
2y dy dt.
Good. Oh, I guess I should still call on somebody for the last one. We don't want to overlook it. Joe, what's the derivative of 13 squared? 0. 13 squared is a constant, so it doesn't really matter what it is. It's not changing, so that derivative is 0. Yeah, we'll just leave it at that. Let's see. Do I have everything I need? I know dx dt. I'm looking for dy dt. But I'll also need x and y. Okay, this told me to find dy dt when x equals 5. Okay, so I do know x, but I don't know y yet. So at one moment in time, not for always, but at one moment in time when x is 5, what's y equal to? Or if you don't know it, how will you find it? Pythagorean theorem, but it's one of those triples. What's the missing side? It's a great day for the saying that, calculus, the hardest part of calculus is the first 12 years. What's the missing side on a 5 blank 13 triangle? Anybody remember it? If not, you got to do 5 squared plus y squared equals 13 squared. 169 minus 25 is 144. So 12. So y is 12. Alright, so let's plug in all the pieces. At x equals 5, y is 12, dx dt is 3. Well, I'll just leave the 2. You can divide through by 2, or you can leave it there. It's not really going to matter. 2 times 5 times 3 plus 2 times 12 times dy dt equals 0. Keep up with all the pieces and plug them in the right spot. So dy dt, I'm going to move over the 2, 5, and 3. This is sort of lazy, but this is safe stop approach, right? Like why risk multiplying things out when you don't have to? If I move it over, though, it's negative. So negative 2 times 5 times 3 divided by 2 times 12. Right, like leave it alone. Why mess it up? I mean, sure, the 2's cancel and the 3 12ths reduces. So it's not difficult to get negative 5/4, but why mess with it? Okay, on these long word problems, it's wise to go back and make sure you answered all the right questions. How fast is the top of the ladder sliding down the wall? That's dy dt. Indicate units of measure. Whoops, we didn't do that yet. So that is part of the answer on this one. And like last time, I didn't keep up with units throughout the problem, but that's fine because y and t, I know the units of y, I know the units of t. So Jace, what are the units of dy dt? All right, what's the units of y? What are our length units? So there's only one unit of length in the problem. Read through the problem, find a unit that represents length, and that is your answer. Feet. How about the units of time? Seconds. So dy dt is feet per second. And again, when I'm grading these, I will attach a point value to units of measure. And even if you can't do any of the calculus, you should be able to get the feet per second, and get you 1 point right there. Yay. Even if I don't know anything else that's going on, I can definitely know the unit. That's the easy part. Feet per second. It's negative. Does that make sense in terms of this problem? Why does that make sense? Yeah, it's going down. Like y is shrinking as it slides down. So it makes sense that y is negative. So there's a couple of built-in checks on these if you'll pay close attention. Let's see. An angle problem. So let's hold off on example 5. We'll do 5 and 6 tomorrow. Again, we got plenty of time. which means that today's assignment, worksheet 2, needs to be 1 through let's do 1 through 6. Oh, that's a radians question as well. Let's just do 1 through 5. And then tomorrow we'll have to do 6 through the rest. But it's block day, so we'll have time to do that, 6 through 17. So 5 problems tonight, but try them, because, calculus marches on whether you're coming or not. So keep up. Do 1 through 5. We'll answer questions on those tomorrow. And then tomorrow we'll do the last 2 examples and look at 6 through 17.